All right, welcome back. We are COMP123 in the summer 2020 semester, and it's week 7, part 2 of our broadcasts. Today we're going to be talking about files and streams. Last day we kind of talked about exception handling, kind of at a high level. We talked about things like try-catch blocks and different kinds of exceptions that we can create to catch problems so our program doesn't crash. But first, before we get to this, we're going to get to this in a second. I want to start talking about assignment 3. Okay, so assignment 3 details. Assignment 3 is going to be due July 24th, so that's out a couple weeks. We're sitting at week 7, so 2 weeks from now, Friday, approximately, week and a half. So you got to get cracking on it. It's not that difficult, but there's a lot of details. Let's go through the details now. So I'm just going to bring up my document. Again, the document is available for you guys up on eCentennial if you wanted to follow along with me. So again, I've got a bit of a diagram for you. So again, I've got like the planet diagram, which you're going to make. It's an abstract class, and you're going to make 2 concrete classes, a giant planet and a terrestrial planet. However, each of the concrete classes, giant planet and terrestrial planet, if you notice the diagram, has a couple of interfaces. All right, so notice that there is I has moons, that's an interface, and I has rings. Let me focus in on that diagram. Okay, so you can see that I has moons and I has rings. And remember, the I stands for interface, so the interface has moons, has rings. So this giant planet has both moons and rings, giant planet, right? And meanwhile, the terrestrial planet has moons, but is also habitable in this case. And again, this is the universe we're creating, where all terrestrial planets are habitable. Not necessarily true. So again, if you look at the diagram, the abstract planet superclass, is basically has a bunch of fields. Now the fields I've used underscore. You can use M underscore when you make your structure. Okay, so this is the structure that I want you to start with. And so this is the first part. First part is, hey, let's make a planet class. Let's make a giant planet class and a terrestrial planet class. These 2 planets inherit from the abstract superclass planet as an example. And then we're going to use them inside of the program class. I've also asked you guys to make a little static function called wait for any key, so that way it'll wait for keys. Again, it's just like a read line function, but I just want you to make it a function instead of just putting a read line. I'm making you guys kind of box it up. All right, so that's kind of what I want you to make. And the details for this, by the way, this thing is out of 100 points, but it's worth 10% of your grade. Okay, so for the first 30 points that you're going to get is basically creating the abstract planet class. This is where the bulk of kind of your functionality points come from. So 30 points out of 69 functionality points are coming out of making the abstract class planet. Okay, so again, I've asked you to make some private instance variables, public properties, the constructor method, a little override for the toString method, which you guys all know how to do. So this is fairly straightforward. Just, you just make stuff. And then same thing with giant planet. I've asked you to make some stuff. Again, this is worth 10 marks. Terrestrial planet, another 10 marks. So it's all together just to make the classes, and then do nothing. Make the classes, follow what I've asked you to do, follow the diagram. 50 marks. You basically pass your assignment. It's pretty straightforward. And then even easier than those are the interfaces. I has moons, I has rings, and I habitable. 3 interfaces. Interfaces are super easy to make. I kind of went over that in my talk about interfaces last week. And then this is where everything comes together in the main method of your program, right? So the main method of your driver class. Driver class, remember what that is? It's the thing that starts, the starter project, right? So the program. And then it implements the giant planet class by creating a new giant planet object. So that's what that is. What is that? I'm instantiating a new object and then making some simple things. So this is why it's worth only 10%. It's not that crazy. However, I am also giving you points for program structure. I've asked you to make kind of create stuff in a certain way. I want you to name things in a certain way. So planet.cs, giantplanet.cs, terrestrialplanet.cs. In the past, for whatever reason, students make their own names. You will lose marks if you do this. I'm asking you to do it. Imagine if you have a client, you're making your coding for the client, and he's asked you to do things in a specific way. Follow what I've asked you to do, please. And then private class member variables, instance variables, use an underscore character or an M underscore character. Either one, you can choose which one you want. Please choose one or the other, not both, when you make your stuff. Okay? Internal documentation is important too. I'm giving you 6 marks, so 6% of your of this grade. I want you to put your name, your student number, the date last modified for each program, each file, right? So make sure you please do that, okay? And then ensure your program uses contextual variable names. So please don't use things like i's and j's. I prefer, kind of some kind of index if you're going to use that. X's and Y's should only be used for coordinates, right? So, you have a lot of room to make your variable names contextual. And guys, this has to be your own code, okay? So share your files on GitHub. I've talked about how to do that. 4 marks for this. 2 marks if you just put your code up on GitHub. And then 2 marks if you actually work with your files up on GitHub. This is again, only 4% of your grade, but please, it's really, really important that you submit this properly. It makes it easy for me to mark. All right, 10 marks for your video presentation on YouTube. 10 marks. This is the thing I was talking about before. We're in a remote learning scenario, so this is a new thing. I want you to make a small slide deck, or Google Slides. You can use PowerPoint or Google Slides to make the slide deck. And there's only one slide in the slide deck. It's a current image of you, so no avatars, no funny images, no cartoons, just your image that's displayed appropriately on the page. So please don't make it skewed. What I mean by that is don't stretch it or squash it or something to put it on the page. This little title page has to have your full name, student ID, course code, course name, and and the name of your assignment on it. Okay, that's part of it. And then you're going to demonstrate your application's functionality. So that means I want you to go through, run it, make sure that the thing runs, and you're going to show that it runs. And what I'm asking for in your console, it's a console application, obviously. You're going to describe for 2 marks each of kind of your different classes and what they do. Okay, so for example, planet. Describe the planet.cs. Describe some of the ways you've created it and what they all mean. I want you to describe this in your own words, right? And then a couple things I'm looking for is sound. I've got to be able to hear what you say on the video. Okay, so if I can't hear what you say on the video, I mean the video is pretty much bunk. It doesn't work, right? So please make sure I can hear your sound. Test your video, all that kind of stuff. And your short video should run no more than 5 minutes. So please don't make a 15-minute video or something insane. Excuse me. And please don't make a 30-second video and speed run through everything. Take your time, explain everything. It's not a lot to go through, all right? And you're going to ask me now, wait, Tom, I don't know how to make a video. I kind of talked about that briefly, and I'm going to go back and talk about it in a second. So submitting your work, I need a zip archive of your project files on eCentennial, and I do need a link to your project files on GitHub. One thing that I forgot to put here, which I got to put here now so you guys can see it, is I need a link to your video, right, on YouTube, and I'll say preferred, or another provider. Okay, I do not want to download your video, so please, it's an important piece. I don't want to download 200 megabytes of video. I should just be able to click on the link and make it go. You can make it unlisted if you want to do video, YouTube. You don't have to show your face. Your video just has to show your screen. All right. The only time I need to see your face is this first slide. That's it. And you're just going to it's going to be a static image of you. All right. So I don't need you to do picture-in-picture or anything funny like that. It's literally you voice-overing your screen. And I mean, I obviously have to be able to see your screen and hear what you say, but this is proof that this is you're talking about it, and all that kind of stuff, right? So please make sure that you get this done. If you don't hand me your video, I will not accept your work. I'm just letting you know. It's like critical for me to get that. All right. And why? Because it's for academic integrity. I'm looking at it to make sure it's you. Right? Remember, I can't tell that it's you. I don't know who you are. I haven't spent time with you. I haven't met you in class. So this is the way that I'm going to do it. No video, no mark. Just letting you know. Okay? How do we record the video? I'm going to talk about that in a second. Okay, so there's a bunch of ways to do this, but I'm going to talk about probably the most common way that I use. Okay, and I'll talk about that in a second. So this is your mark breakdown. So functionality, 69 marks, program structure 11, internal documentation 6, version control 4, and video presentation 10. But like I said before, no video presentation, no mark. So this is kind of like very, very important. I can't stress it enough. The whole thing is worth 10% of your final grade. And for each additional day you're late, so if you're late, I'm going to deduct 20% for each additional day. One thing to note is external code, if it's not your own code, if it's somebody else's code, right, or something like that, and there should be no reason why you're using somebody else's code for this thing. But just in case there is, you need to get at least the code source. You have to quote it and set it in your internal documentation. It can't encompass more than 10% of your code. So anything more than 10% of your code, and this is only if you want to make something fancy or whatever. Again, any more will be considered cheating. I don't want you to copy or use anyone else's work. This is an individual assignment, so that you're not working with anybody else on this. Guys, my Google Foo is very, very strong, which means I'm going to be able to tell if you've taken this stuff from somebody else, chances are. And there's a bunch of different ways to do this. It's not easy. It's not difficult for me, to figure it out. So please, I'd ask, and for your own benefit, make it your own. Do your own work, okay, on this one. So you can't have somebody else do it as normal. I'm asking you to do it yourself, and the video is going to help me with your academic integrity. I want you to show this is who you are. And basically what you're doing is when you're making that video, you're making a little contract saying, here's me, I made this, and all that kind of stuff. Okay, it's not like, hey, I don't know how to do C#. I'm new to C#, so I used my friend's code and blah blah blah. That's not going to fly, guys. You'll get 0. All right, so please don't do that kind of stuff. It's not good for your academics. So this is what you're doing. This is what you're making. This is the diagram or a map of the classes you're making. Now, how do you record? That's the question that you've asked. So the tool that I use to record with, like I said to you before, and it's just a tool that you can download for free, is called OBS. Okay, so there's OBS. And I've talked about this in other classes, so for people who are in other classes with me, please forgive me, but this is the tool that I want you guys to use to record. Okay, I think it's a good tool. I think it's free, and it's very, very easy to set up. So notice in the tool itself, you're going to see your screen like this, and there's going to be different parts of your screen that you can assign. There's some tutorials online for how to make this tool work, and I highly recommend you stream to YouTube. Okay, it's a kind of a one and done deal. You can actually, there's 2 ways to do it. You can stream and on YouTube, and it automatically records. Again, you can stream to a unlisted to create an unlisted video, or you can just record locally. So if you click on start recording, it'll record locally, and then you can upload it to YouTube or another provider. And again, you don't have to make it public. If you don't want to share your video with everybody, just me, just make it unlisted. And as long as I get the link for your video, I'm good to go. Again, I will not accept 200 megabytes of an AVI file or an MKV file or anything else like that. I'm not asking you to make a video file and give it to me. I'm asking you to make a video on some kind of streaming provider. It could be Twitch if you really want, but I think YouTube is just easier for you to do, and it's good like that. How does it work? So if I'm going to show you what I'm doing right now. Here's me. I know this is a little thing, but you can see that here I'm in my little corner. You don't have to do this part. What I'm actually doing is selecting my screen in the background. So notice I have my video capture. I can turn that off and on, right? So this is just a layer that goes on top of the video, right? So that's one thing I can do. I can adjust my camera, what it's looking at. I'm also using a bit of a green screen, so you can see that there's like a little bit of distortion in the background. My display capture, I can display capture this. This is what it's another layer. So these are all things that are either visible or invisible. And for example, if I don't want to just capture this display, I can just turn it off. And if I do, then the video won't be sharing anything. I can turn that off and on at will. That's something that I'm doing. I can also turn on another display, so I can look at, if I have multiple monitors, I can record from that. And in your settings, you can adjust things for example, the stream. So if I click on settings, as an example, you can see that I can kind of pick my stream key, which is automatically generated by YouTube. If you notice, it says YouTube Gaming, primary YouTube ingest server. That's the settings that I use, and that's really it at a very high level. I mean, it doesn't really take much. It's not high tech or anything like that to do, and there's a ton of tutorials on how to make this go. Again, all I care about is seeing your screen. I don't need to see your face. It's not important. Like I'm layering my face because it can be interesting to see you, but you don't have to do it. So this is kind of the app. It's free, and I think it's even cross-platform. You can download it for Linux, Mac, or Windows. So there's not a big issue on any of this stuff. Okay. So that's how I want you to do it. And again, it's going to be through either by you creating a link, a little PowerPoint with a single slide on either PowerPoint or Google Slides. That's all. And that Google Slide thing is just going to be your first slide. The rest, all I want to do is I want you to show your background and actually show me your Visual Studio. Step through the app. So again, you'll be talking to it. Like for example, hey, here's my app, and this is how I did it. Here's my, my program. Here's my planet. Here's my abstract. All these things. I want you to go through it. Any questions around what I'm looking for from a recording perspective? It's worth 10, even though it's only worth 10 marks out of your assignment. I'm not going to accept your assignment without it. Okay, so step by step. Yeah. Do we use comments in Visual Studio to make documentation? Yes, I'll talk about that in a second. Let's talk about it. So one thing before we get into our meat and bones for today, I'm going to make a new project here. So I'm going to make a new one called the .NET Framework, C#. Again, console application. We click next. I'm going to make a new one for today. So it's going to be COMP123, and again it's M2020. Lesson 7, part 2. Okay, so this is the first part, and I'm going to show you some tricks to make your job a little easier for this thing. Okay, so please watch carefully. So I'm going to create, and just like before, when this thing is created, what it's going to do is it's going to create an empty project for me. And remember that I'm also using ReSharp or C#, or C++ if you're going to use C++. And when my white screen goes away, I actually will be able to show you Visual Studio 2019 in its updated format. I like when Visual Studio 2019 does this. Okay, I don't like it, but I'm just, being facetious. All right, so here you can see that I've got my program. Notice that it's pretty big. As an example, I recommend this. I recommend when you're streaming to me or you're displaying stuff, don't make your program really, really small. Like, don't zoom out like this big. If you can't see it, I can't see it, right? Like, zoom in, and you can do that with the Control key, Control and scroll wheel. Zoom out to a comfortable place, a comfortable level, so that it's pretty big. I mean, you're demonstrating this. You're not coding this, okay? Dark mode is fine. You don't have to go with the light mode when you do it. Okay, that's important. One thing else is when you're doing C# and primarily for C#, Microsoft provides something called a class diagram. Now, it's not available to you, as an example, if you just installed Visual Studio 2019. So what you want to do is you want to type in Visual Studio installer by pressing the window button and kind of searching for Visual Studio installer. Press enter. It's going to ask you if you want to do this kind of stuff. It may ask you also to update your installer. I did this today, so it won't ask me to update my installer, but for you it might check for updates and see if there's an update for your installer. Okay, and again, you don't want to do this right now if it's updating your stuff. I just want to show you the process. You can watch the video later. Okay, you want to go into more. And under more, you want to go into, I want to modify, right? So that's what I want to do. I want to go to modify, not more. When I go to modify, right? Here's modify. Then you're going to see all these things like ASP.NET and so on, right? All these things. I want you to go into individual components. And then if you scroll down, right, under individual components, you can also search, right? But I want to show you where it is. So there's something called Class Designer. I want you to definitely clicking that on. Okay, so Code Tools, Class Designer. Please click this on. All right. So that is the one thing. And if you actually search for it, so if I go class, right, Class Designer is the thing I want you to turn on. Okay, so it's an interesting tool, I think, that we can use for C#. And again, you can see that I've got a bunch of other things that I've loaded up, right? It used to be called, and there's also other things that used to be here called the class diagram, okay? But basically, that's what we're going to make. You need the class designer in order for us to make our to do the next thing that I want you to try out today. All right. So again, it's an individual component. You add it in, and then once you've added in, you have to install. Okay. So that is what you have to do. So what does the class diagram allow you to do? Well, only for C#. Okay. I want to right-click here, and what I can do is I can go add, and then if I want to, I can go add new item. Right, I'm adding it onto the project, and if you look through, if I scroll down, right, there's something that you want to do called class diagram. So when you start your application, you can go to class diagram, right? This is class diagram 1 by default with a CD, right? And for today, we're going to do like kind of a a class diagram for our I/O, anything we do with our I/O eventually. So we're going to put this in, but I want to show you what you can do with it and how beautiful it is for you to help you code. Okay, so I want to click Add. Okay, so there's my class diagram. Yay! And what you can do is, if I right-click now inside the class diagram and I click Add, I can add a new class. For example, let's talk about that Vector2D class that I created last time. So class. And I'll call this Vector2D. Okay. Notice what it does is automatically starts scaffolding out your Vector2D in here. Your public access, you can make it internal or default, right? And then you can also specify an existing file if you'd like. But here I'm just going to make this new file called Vector2D. Okay, new class. Okay. So what it does automatically is over here on the right, it creates my class file. I'm not looking at it yet. I want you to look over here. All right. So what you can do here is you can expand this class diagram, right? So again, you can see that this is collapsed, this is expanded, and on the top here on Visual Studio 2019, you can also make it kind of adjust your span. You also want to click on Display Full Signature. I like that one, and I'll show you what that does. So let me make this bigger. And what I can do with it, right, is if I right click, I can add methods, properties, fields, everything I want, a constructor, whatever I want in here. So let's start off with my fields. I want to make two fields, right? The first field I want to make is going to be called X, right? And notice, is X the right name for my field? Well, it's private, right? So if I want to make a field, so let's just go back. I can go to properties, right? And on the right, it's going to show up my name. I can change it at any time. So I can say X or M_X if I really want to go crazy, right? So now it changes it over here. So this is what it looks like. Again, I'm just scaffolding, right? I could also add, instead of a field, now notice, so fields are one, right? I could add a property. So I can say, okay, well, I want a property called, X as an example. And notice it says get set by default. So it kind of creates some stuff for me, int x, or just x. I can rename it x, right? If I wanted to make this, you know, kind of thing happen. So, okay, cool, Tom, you're going to say, who cares? Why are you showing me this? Because if I go to my vector2d, it's already made, which is really cool, actually. So what you can do, and I can modify it after. It's not like it's set in stone. I can say, well, I want to get x, right? And just like we did with our getter, I want to return this dot m underscore x, just like we showed you last time, right? That's what this does. Okay, so get x. Okay, and it says what's the return type, right? So it says return type is void, right? So why is the return type void? Public int, right? And think about this too, right? Like what the return type is for x. If I want to do a getter and setter, right? I don't need the x and stuff there at all. I can just do this, return. It says also that inconsistent body style, who cares about that? And let's go to the next one. I want to do a setter for the x. So set. And then I want to say that this dot x is equal to m underscore x. Actually, m underscore x is equal to value. That's what I really want to say. Value is a special keyword, so when you attach stuff, then you can do this stuff. And I've got my property. Now, what does it look like on my class diagram? Same. There's no difference, really, at the end of the day. Now, x is both integers. What if I wanted to change it in my actual code? Well, I can do that. I can say, well, I want floats for x, right? So it's not just, you know, this that I want to change. And if I go back to my class diagram, it's float now. So why do I care about this? Why am I showing you this? It's a quick way to scaffold out what I've asked you to do, which is this. I've given you this. Make it. Use it, right? Because you can do everything here pretty much by using your class diagram to start you off, at least. And it'll be pretty accurate in terms of what I'm asking you to do. Okay, so this is good. So I got my vector2d. Let's add a couple more things. By the way, you can also look at this down here with class details. So you can see that I have properties on the right if I want. I can use the property way. Or I can just add stuff here. So I can say, well, I want a new property called y. It's going to be of type float, right? It's going to be public, right? As an example. I also need an m underscore y, which is going to be float. I need to, it doesn't do all the coding for you. Float, as an example. So see that that's done. If I go back now, if I save my diagram, go back to vector2d, it's done, but this is wrong. So that's okay. We can fix this by doing kind of the same thing. I'm just going to copy paste. But it does scaffold stuff out for me nice and beautifully, right? I mean, I don't have to work as hard to do this. Obviously, this is not x, it's y, and this is also y. All right, so we've got our properties, x and y. And you know what? I would love to have a constructor. Let's do it in the class diagram without me, kind of breaking a sweat here. So I'm going to add a new constructor. All right, so there's my constructor, vector2d. If I want to modify the constructor on the right, you can see that I can do it using the property window. I can totally do that, right? So again, whatever I click on here, it's contextual on the right. It talks about custom attributes, file, method signature, right? You can modify all this, and especially here in the class details, right? So I've got vector2d, right? I can add a parameter right here by kind of going in here and say something, well, I want x, right? And I also want y. I want to take x and y. They can't be strings. That's just silly. They got to be floats, right? Okay, here we go. And this has got to be a float as well. Okay, so float. Modifier. Are they? You know, you can't have a modifier here for this. If I wanted to, I could though. So there's some modifiers you can choose. Ref or out are the two things you can use if I want to make a reference type or not. And now you can see that again. I have my constructor and it takes a float x and float y, right? It doesn't actually write the code for you, but what it does do is do this, right? So if I go down to my constructor now, you can see or wherever they put my constructor. Here's my constructor up here. You can see now that I have float x and float y, and it's going to throw a new system not implemented exception. Isn't that interesting? Automatically, because you haven't made this, and it's for you to basically say, hey, I'm not done. Now, typically what I do when it comes to documentation is I just use, kind of like, here's my private instance variables. These are also called fields. You can call them whatever you like. This is my constructor. You might have more than one. The order that I like is putting my properties before my constructor, but it doesn't really matter. I mean, if you're scaffolding out, I'm fine with this as well. And then here are public properties. And then you can have other things in here, for example, like methods. Let's make a method, a couple of methods. So maybe I want to do kind of like dot product method, right? So we'll make it so that you can do dot product when you instantiate, or let's do a static method. It doesn't matter, or a string method, whatever. If I do a toString method, if I go add and I want to do a new method, I can do that too, right? So I can do kind of like a public override. So notice over here on the right, it's public. I can also put custom attributes in here if I'd like to, any custom attributes that I want. The inheritance modifier that I want to put in, I want to use override. So I want to start scaffolding it out, right? This new method that I'm making, right? The name is not method, the name is toString, right? The toString method. And you can also do its return type. My return type is obviously going to be a string type, right? So again, I can scaffold it out on this side, right? And then it returns a string. So that's what it returns. Returns a string. And so you can see that I've kind of scaffolded this thing out, and it looks like a little method. So methods, the constructor method is here, right? And the toString method is here. Okay, and let's see what it looks like on the class details area. So class details, you can see that I've got a toString method. It's a public modifier as an example. And I can add parameters if I want. Cool. What does this look like from a coding perspective, right? So again, this is just an exercise on how to do this. There, hey, look at it. It says returns a string, and it actually gives me a little bit of comments. So public override string toString, it's going to throw this exception because we haven't implemented it, and let's just do it. Let's say it's going to return the string type, which we talked about before, right? So I can make an output string from my to show x and y, right? Or I can just do the old school way of doing it, which is I want to open this up. I want to say that I want to have this dot x, and then plus a comma, space, and plus this dot y, plus a space, or this as an example, and that is my toString methods, right? So this is my implementation details, right? So it gave me this, and if I don't want it, the triple forward slash is kind of really interesting. I can just go triple forward slash, and it does a little summary. So it returns whatever I want it to return, returns a string, right? And then the summary basically says you can kind of put details in here for your documentation. This method overrides the built-in toString method. It returns a string that is formatted as x, y, where x and y are the properties, property values. There we go. Okay, so some little method signature I've kind of put together, and there you have it. If I go back to the class diagram, you don't see that here for your vector 2D, but this is kind of interesting the way you can scaffold it out. It's great, right? So it kind of organizes your code. It makes sure that you match what I've asked you to do, as an example, from an assignment perspective, and I think it's an easier way to get going. Okay. So questions or comments around this? Because I know some of you are like, wait, isn't that cheating? I'm not actually coding. I'm using some kind of visual coding style, and I don't like it. I'm a developer. Yeah, it's okay to do it this way. There's nothing wrong with you scaffolding out your classes, and to do this. There's many ways to do the same thing. One thing that it does for you also, again, if you right-click anywhere in the class diagram canvas, I can add an enum, an interface, an abstract class, a struct, and other things, even comments, right? It allows you to do everything in here. You can also, it'll also show you the relationship from one class to the other, right? So, which is really kind of interesting. And I'm going to save this. I'm going to come back to this in a second. Let's take a look at what it looks like if I did it for the other example that I've done before. And I've prepared that for you. So if I go out, let's just leave VS 2019 for a second. And I'm going to come back to this, right? But let's go back to the previous code that we had. I don't know if you guys remember, but we did that other example where we had part 5, or lesson 5, part 1. What we had was a game objects and enemies and bosses and all that kind of stuff. Remember? Well, the great thing about the class diagram. So if I actually show you the class diagram here. So here's the class diagram for this other code. You can see how it creates a relationship for you from the code that you've already created. So even if you do this secondary, like later on, it'll actually show you all the details. So this is an example of the completed vector 2 diagram, what it would look like as an example, right? So you have your operators. You can see that you've got methods. Here I added fields, not properties, right, for my vector 2. What the transform class, notice that there's no relationship because we don't have an association here. I'm just using a vector 2 to make position, rotation, and scale from before as if they're types, as an example, right? But here you can see that there's clearly an association, and it uses the kind of the arrow diagram, the arrows to point to each of these things, and I can actually look through and expand. If you go up to the top here, you can expand each of the class definitions to get details on all the the properties and methods and fields that are included in each of your classes. So this is kind of, I recommend doing something like this. I think it's good practice for you to kind of visually see how things are laid out for yourself. I don't think it's a negative thing at all. So that's one way of looking at it. The other way of looking at it, and I'm just going to kind of close this one down for a second, is, and I'm using this older kind of project that we had going on. If I click on the solution, right, the solution also gives me the ability to do show on code map, which is actually kind of cool. Again, you may need to install a component in Visual Studio 2019 for this to go. But if I click this, it kind of shows me my class in a different light altogether, right? And it kind of does the associations for me. It takes a second to kind of generate, but then when it's done, so it's done, right? You can expand this and expand. This is the solution on the green side. Inside here, that's the class, that's the actual project, and you can see what it does is it creates this almost like a mind map of how everything links together, right? And you can display this in different ways as well. I just wanted to show you these visual tools that are part of Visual Studio. That's why it's called Visual Studio, actually. And you can choose a layout. If I want it so that I can show my class from left to right, if I was going to do kind of a demonstration or something like that, I can kind of say, well, program uses or calls the boss enemy. It also calls the enemy. It also calls the player. You can see these green lines, and you can actually look at the legend of what these things mean, right? So, so inherits from, implements, calls, like all this kind of stuff is really neat. It actually shows you the difference between a class and a struct, as an example, and a bunch of other stuff. So this is kind of really neat. Another view that you can use that's built in. Again, there's nothing that's wrong with looking at it this way. And again, this is a visual representation of the relationships in your class. One thing I know for sure, I'm not going to save this one. One thing I know for sure is when I present a new project to another developer, and we kind of talk, and we say, hey, so I kind of made this new project. The first thing I get sometimes from a developer is, hey Tom, can you show me your class diagram? Because when I see the class diagram, I'm able to understand, I start understanding, how things link together, right? It's a high level view of how things, are connected. And when I see that, I suddenly get an understanding of how the program works. All right, let's see some other comments here. Do we use comments? Is there a special way we need to use regarding our name, ID, documentation, sir? When you hand in your zip file, what I'd like you to do is kind of name it, like, at least if you could make it assignment 3, that would be okay. Remember that when you're handing in your links, your GitHub link, and you're handing in your assignment zip archive, please, I will not accept RAR archives. Do not hand me a RAR archive. Okay, so no RAR files. Don't use WinRAR. I highly recommend you download and install WinZip. Okay, or sorry, not WinZip. 7-Zip. WinZip is old. 7-Zip. I always say WinZip for some reason. So 7-Zip is a free download. Download the 64-bit version for Visual Studio for Windows. And then when you run it, what you get is a contextual menu in your so let's say, for example, I want to show you my File Explorer. Here's COMP123 midterm exam, which is, by the way, coming up. It's coming, right? If I right-click and I go to here, then you can see that I can, it'll allow me to expand here. That's what it'll allow me to do, as opposed to what I normally do. So it says open with, I can open with what I want. What I don't want you to do is I don't want you to send to a compressed folder. Please don't do that. That's just bad. So let me show you what that looks like. So if I install this with you, let's install this together. So 7-Zip. I already have this, but let's just say I don't, right? So download 7-Zip. And let's install. Again, if it already exists, it's going to overwrite. Okay? It's a very quick install. And now when I go back up and let's just right click here, a lot of times it gives me, I'm just going to actually double click here to show you something, because yeah, it's on my OneDrive. It gives me a 7-Zip context menu, right? So I can just go extract to blah blah, right? And the same thing goes if I want to zip something up. So if I go back to, let's suppose I look at my assignment. Let's say I want to kind of zip up my assignment documentation. I can right click here and I can go to 7-Zip, and then I can just say, add to abstractplanets.zip, right? And when I do that, it literally just compiles everything. Yeah, it's being made by, I'm using it right now, that's why it didn't work. But that's how it works. Okay, so that's really, how easy it is, and that's all you need to do. So if I was going to zip up a folder, okay, that's something that we'd have to try and do. Let's try that. So remember where these folders go. If I launch Visual Studio 2019, it's going to tell you where your folder structure, where your folders are anyway. Look, it says C, users, Tom, source, repos. That's the last thing that I had for lesson 7. Let's pull up lesson 7 because we're going to start this in a second. And I got to do some I/O with you guys today too, not just talk about assignment. But if I pull that up, so I can also look at it. Let me just close this class diagram down. Good. So the class diagram is actually a file, right? You can open it up by double clicking if you want to, not a problem. But I can also look at the solution by opening Folder and File Explorer. If I open Folder and File Explorer, I can see that this is my path, source, repos, whatever. So if I can edit the address, right? And if I do that, you can see that I can see the path. This is my path, right? Okay. So here, what I can do is I can do it in two ways. I can go to repos, and if I want to zip up, let's say the previous one, because I'm using this one, I can't do it, right? You'd have to shut down Visual Studio to do it right. But if I want to, let's say, zip up part 1, which I did on Monday, I want to take the entire project folder, okay? I don't just want the solution file. Please do not give me the solution file. This is not what I want you to zip up, okay? You need to zip up everything, including this, like at this level, right? So way out here in your solution level. Okay, so right click here, you're going to zip 7-zip, and you're going to add to COMP123 M2020 lesson 7 part 1 zip, and it's going to take a second, and it's going to create a zip archive. This is what I want you to upload to eCentennial, please. Okay, this. I don't want you to go in here somehow and pick files. I don't need you to do that. Don't pick my CS files and zip those up. Okay, zip up the entire thing. Not here either. This is not the right level. If you see a solution file and you're zipping it up here, no, I want you to come to this level. So the level where you see the entire solution as a folder. That is what I want, the entire solution folder, please. This way, for me, I want you to think about it from a marking perspective. I'm going to get this thing and I'm going to unzip it, run it, and it should be good. Also, I'm running Visual Studio 2019. If you're running Visual Studio 2017, guys, it's time to upgrade. Please upgrade to 2019. I'm not going to accept your 2017 projects any longer. All right, so that means you need some work to do. You got a couple weeks to get this done. I don't need you to do upgrade to 2019 today, right? But 2019 is a free download. 2019 Community Edition is all you need to make your project run. Okay, so please get that done. Is there any other questions before we move on to actually the work we have to do? All right, let's get moving and grooving on this thing then. So that is assignment details, and we're into lesson 7 part 2. This is what we're doing. I've made a little vector 2 class. We may or may not use that today. Okay, we'll see how that goes. I'm just going to close these down. All right, so close those down. And I'm also going to shut down the Word document. Again, don't hit me up with questions around the assignment 3, you know, on Thursday, July 23rd. By the way, Tom, I don't get what you want me to do on the assignment on Thursday, July 23rd. You know, and don't hit me up on Friday, July 24th and say, Tom, can I get an extension? No. You've got a week and a half to get this done. Please plan accordingly. This course is worth the same as any other course that you guys are doing. All right, so please do that. Unless it's some kind of emergency, family emergency or something else like that, you know, I won't accept an extension. I won't accept a request for an extension. Okay, and not because of anything else, because there's a lot going on for everybody, for you and for me. Okay, so let's continue with this kind of stuff today. So let's talk about this. So here is programming 2, and we're talking about file manipulation at this point now, files. So we're going to talk about how to do things like file organization, what are file streams, and so on. Okay, we're going to kind of hit this again when we talk UI. Next week we're going to start user interfaces, right? So this is kind of the last week we're going to be doing console applications. Next week everything is user interfaces. All right, so it talks here about storage and difference between temporary storage and permanent storage. That's, you know, kind of a computer stuff. I'm not going to go through this. Different kinds of files, text files and binary files. You guys should know about this. Text files are again are clear text, so you can actually read the text. Binary files are stored in kind of a format that you normally can't read. Okay. Now, the advantages of text files, you can read them and you can modify them. Advantages of binary files, they're unreadable typically, and they're more secure. Okay, and they're much quicker to load, especially if it's a larger data than a text file. So a couple things when we talk about file reading and writing is we want to be able to write to a file and read from a file. Those are important pieces. We also have to combine or think about our path where the file exists, because that's also important. And again, we're going to have a couple of built-in classes, one of them called file, the other one called directory, that we can use to help us. Okay. And we need to use the system.io namespace for this to happen. System.io, which, by the way, if you look at Visual Studio 2019, on the top here, system.io is not by default included as a using. Think about using statements as including or importing different features of the C# programming language. C# is modular in that we only add the features that we need when we need them. If there's some features that we're not using, then notice that these are grayed out because we really haven't used threading tasks here. Okay. So let's keep going. So again, there's some methods for this that we're going to be using for file and directory. If I want to make a file or directory, I can use the create or create text, methods. These are all methods we can use. We can check exists, returns true if the specified file exists. It's important to do as well. And here's an example of how this would work. So again, this is starting off, right? So what I want to do is I want to say that my string name, let's say I'm listing for a file name, and I'm going to say file name is equal to console.readline. I'm listening for a file name that I'm going to put in. And then I go if file.exists file name. So I pass in the file name that the user enters to file.exists, where file is the class that I'm using, right? So that's important to look at. So that's how it works. So let's see if we can do this. And where does it actually look by default? Okay, because I think it's important, okay, to understand this kind of stuff. And we'll just do this one thing, and we'll go for it. Okay, now if I start typing, again, I want to do kind of a wait for any key, that whole idea of a static. So let's make and instead of doing a just kind of a console read line, let's do a static wait for any key kind of thing, right? So I'll make a static, it returns void. We'll make a new method called wait for any key, right? And what this method is going to do is literally do console readline for now. Console.readline. Actually, let's do read key, right? See what the difference between that and console readline is. And then I'm going to call it down here. So wait for any key, right? If I was to run this thing, wait for any key, it's going to ask me for a key. I press the button, it's gone. So any key as opposed to an enter, right? Read key. Part of your assignment. Let's continue. So then I got that, and now what I want to do is kind of do a console dot write, a console write, and I'm going to say something like enter the file you wish to open, right? And then after this, I'm going to do a console.readline, right? And the console readline, it returns a string from the console, so I'm going to store that inside something called file name. So again, we can use a couple ways to do this. I can use var file name. I like to start with var because a lot of times what it does, if you hover over it, it tells you the type, and then you can replace it later. So string file name, console.readline, especially if you're using a new class you've never used before. It's a kind of a quick way of figuring that out. Console readline, I'm going to read that in, I'm going to store it in file name, and then what I want to do is I'm going to say if file.exists, right, and I'm going to pass in file name, right, then I can say something like, console write line, something like file exists. Okay, pretty straightforward. So let's see how this works. And what did it do? Look, I didn't even have to go and do using statements. As soon as I did that, it included all this stuff. System.io, it actually put that in. I didn't do that. It did it automatically for me. Because I'm using R# or C#, that might be doing it. If it didn't do it for you, you need to put this line in using system.io. If I don't have this line in there, as an example, I'm going to get this messed up little error here that says, hey, something's wrong, right? And you're going to get some kind of indicator on the right, on the left, that's telling you, hey, you need to fix this, right? And I can do that by just simply importing the type system.io file, right? Or I can, there's some, again, it says system.io, multiple choices. Which one do I want to do? I can do any one of these things. System.io, right, is really what I want, right? So here it's telling me specifically just, kind of system.io, import type file in the file, import type file in the project, import type file in the solution. So there's different options here. We don't want to do any of those things. We want to just put back system.io. By the way, you don't have to put them in any particular order. If I just go using system.io, I'm okay, right? If I go io.file, right, as an example, that really doesn't kind of exist. I could call it explicitly. I could say something like, hey, instead of just using just putting file here, I could use the fully qualified name, system.io.file, which is really what I'm doing. This is the namespace. If I hover over, it says namespace system, namespace IO. So there's a namespace and a namespace. A namespace, just like we have here, COMP123 or whatever. It's just a container for the class, right? That's what it is. And then file is the class file name. All right, so we could do it this way as well. And this is more explicit. I don't have to use using statements in this case. But if I'm going to be using file stuff a lot, then it's okay to use using system.io. So using system.io. Okay? So that kind of satisfies requirements. Let's try it out and see how it works now. As we do it, so it says enter the file you wish to open, right? So I'm going to open something called program.cs. Let's see if it exists. And then I press enter. And then it doesn't do anything. It didn't actually print out file exists. That's interesting. Well, I can see program.cs right here. Where is it looking? Where is it looking, right? So, so let's see that. So what if I do an else? Let's do else, and we'll do a console write line. It's not a great use of else, but whatever. Let's just do it, and we'll say file does not exist, right? Like yelling does not. Okay, let's try that again. And also, we want to say, you know, something like thank you for your entry or something like that, right? So, thanks. Whatever. Some kind of thing to tell the user that it's successful or not. You know. Also, you don't have to do any of that stuff, but I'm just kind of putting something in there so that we have some kind of structure. I'm going to run this thing and see how it goes. So again, let's try that again. So program.cs says file does not exist. Wait a minute, but it does. I mean, I see it right here. Look, it's right here. Where are we looking, right? So let's go back. So I'm just pointing this out because, you know, when you start doing file I/O, you should be interested in where this is looking, right? Like, where are we looking? So let's take a look at our solution again. If I go out to the, folder structure, right? Here I am in my solution. Inside my project, this is the level that I'm at with my project. But when my project gets built, it looks in a specific spot. For example, in my bin debug folder, right, I have these files, an executable file, I have this other file, this configuration file, and a PDB file, a program debug database file. And the reason why I'm in bin debug is because up here I'm in debug mode, right? Look, debug. I can choose release. That's a different configuration mode. By the way, release mode doesn't do good debugging. We typically start to our application coding in debug mode, and then when we're sure things are working well, we go into release mode, because release mode actually runs our code faster, right? So that's how it works. But for now, debug is the folder, if you think about it from a configuration perspective, where this is going to go. So let's make a new file to test inside of our folder. Let's make a new file. We're going to make a new text document, and we're going to say something like, call it names.txt. Okay, or let's call it even better, positions.txt. Here's positions.txt. Okay, yay, positions.txt. I want to open this file now. I want to see if that file exists. Okay, and it's inside of my bin debug folder. I actually went into the file system for this. So here are my repos. I went into part 2. That's the actual solution folder. Here's my solution. Inside my project folder, named the same thing, by the way. Notice the project and the solution are the same. And I go into my project folder, and then it's not here. This is where my files are, my source files. I want to go into my bin folder, my debug folder, and then that's where I want to put this. Okay, let's see if that works now. So I'm going to run this thing again. So I'm going to say I want to look for a positions.txt. Does it exist? Hey, file exists now. So you can see that I'm proving to you where the file looks at. file bin debug, right? That's where it looks. Now you should know this already from last semester, but sometimes, you know, depending on the professor you have, they may have not showed you this or whatever. It's okay. So file exists. So we know that's what file is. File actually is a class, and there's different methods that we can use of that class, and one of them is file exists. You can also look at file get creation time, file get last access time, file get last write time. These are pretty cool things for file. And again, you can see that I can do a bunch of things. File create text, a text file. File delete, file exists, which is what we've done, right? File move, we can move it to a different place, right? And so on. That's files. Same thing with directory. We can create directory. I can delete, I can get creation time, I can get directories, returns a string array that contains the names of the subdirectories in the specified directory, get files, get last access time, get last write time, and move. Okay, so this is all the stuff that we can look at as well. And again, here's an example of the same idea, but the directory name. So if I want to look at the directory name, does it exist? The directory name, if it does, it contains the following files. We can loop through. This is interesting. Directory.get files. I can loop through all the files in the directory, and it'll output each of the files as a list of files, as an example, in the directory. So list of files, notice what list of files is. It's a string array. That's what this thing is. And list of files will receive a reference to the list of files from the directory class, right? So get files actually is going to return a list of type string, a string array. Okay? And it does that. I'm not going to go through that. I'll leave that to you. Okay, and then how do we organize file data? That's interesting as well. You have different kinds of information, and we want to specify our last name, you know, as an example. So if the record is Lee and here's Smith, well, Lee, if the record is called Lee, then the character L, E, and E is inside the last name field, right? And that's how it works in terms of the hierarchy of kind of file information. So there's a field, a character or group of characters that has some meaning, and a record, a collection of fields, okay? And that's how it gets stored. Okay, so I know this is something you know already, but I'm just going through it because some people forget how it's stored. Okay, so we have input and output, and we're going to use something called a stream. So one thing is to actually detect files and directories. Another thing is actually to output to a file or read from a file, right? So we have two types of streams as an example, an input stream and an output stream, okay, of different kinds. And here's some example of streams that we can use: a console in and a console out, right? Console error. Those are kind of three things we can do with stream objects in C#, right? Console itself is a type of stream, right? Because we're getting input from somewhere. Console.writeLine, right? But you can do different things with the console as well. So what we want to use is, there's two streams primarily we're going to be using. Stream reader is what the stream is called, and stream writer, which is the input. So we can input or output. There's also called file stream. File stream does both input and output to a file. Okay, stream reader, stream writer, and file stream. By the way, these three things we're going to use when we do UI starting next week. We're going to start using these things. All right, so you can see that streams. I can look at the stream name, so it gets the name of the file stream, whatever that is, right? The position of the file stream, can read, can see, can write. These are just booleans that basically tell me, am I doing that, right? The length of the file stream in bytes and so on. And similarly, I can create a new file, right, as an example. So it creates a new file if the file already exists, is overwritten, and create a new file if the file already exists and IO exception is thrown. Remember we talked about exceptions last day? You want to be able to capture this if I try and create new as an example. I can open, which just opens a file. If I try and open and it doesn't exist, I can open and then create a file if it doesn't exist. Okay, that's what kind of happens. So these are elements of my read stream, if you will, right? And I can also read. I can read data from the file. Read-write. I can read and write data to the file, and write only writes data to the file. Okay, so kind of interesting for file access, my file access enumeration. So here's an example of my file stream. So I can say, okay, I got a new file stream. It's called outFile. I'm going to make a new file stream, and I'm going to kind of pass into it some kind of text, which is the file name, the file mode I want to use as an example. So file mode create, and then file access write. So I'm only writing, not reading and writing. Okay, so that's what this file stream does. Okay, but I've made something called an out file for me to use it. Okay, so stream writer, right? I create a new stream writer object that uses the file stream I just made. So I configure the file stream first, and then I pass into it some kind of out file. Here I'm just writing. And then it says console write, enter some text, right? String text, console read line, I can read from the text, right? And then I can use my writer to write line, just like I can use write line to the console. I can use write line to write a whole line to the file, okay? And then what I need to do is I need to close up, do my closing operations, okay? So I need to close the writer, I need to close the out file. If I don't close this up, I can have file corruption if I'm not careful using this methodology. Okay, so let's try that. So I'm going to do things slightly differently. I want to, instead of doing this, I'm going to put this up on GitHub in a second, right? This is just an example of how files work and how I can read from files. So I'm waiting for any key. I'm reading from a file, but now I'm going to ask for a couple things. I'm going to say, I want position in X and Y coordinates. Okay, we already have that vector2 class, right? I want to use it. So let's do that. So I want to say that vector2d, and I want to call this position, right? Here's my position, right? And let's instantiate it is equal to a new vector2d. So by default, my vector2d doesn't do anything, doesn't work because I need values, an X and Y value for these things, X and Y float values. Let's give it some default values here as an example inside of our class, just like we did before. So if I go back to my class, you can see here that I can say float X, right? I can give it a value by default of 0, right? I can also give float Y a value of 0. And then what I want to do in my constructor, which has been unimplemented, I can go through here and I can say that this dot x is equal to x and this dot y is equal to y. You can also just use x and y, but this is more explicit in this case. Notice that it lights up because x and y here are exactly the same as x and y here, and it's just easier and less ambiguous a lot of times to use the this keyword in this particular context. Okay, so this is good. I've just revamped my vector2d class, and here in my program.cs class I'm actually going to make a new vector that's 0, 0 right now. Okay, so what I want to do is I want to enter x and y coordinates. So let's do that. So I'll say console write line. Let's say enter the x coordinate, right? So that's what I want first, and let's read that in. So I'll say that position.x, right? I want to read this in. So let's see how this works. Remember, when I do a console read line or a console read, right? So if I do console.read, right? It says reads the next character from the standard input. If I do read line, I read a string, which is what I want. But I can't do this. Remember, we tried to do this last day. It needs to convert a string to an int. So again, there's a couple ways to do this, but one of the ways I like to do is do this try-parse stuff, right? Try-parse. So remember how we can do this? We can say that, because remember, the user is going to provide information that we can't depend on, right? So I could wrap this in a try catch. That's one way I could do it. Or I could say if, right? And again, I know it's float that I'm getting in for x and y. Float dot try parse, and I'm going to pass in the string that I want, which is going to come from the console, right? And then I need an output value. So where is it going to go? Well, it's going to go to position.x, right? Position.x is where it needs to go, right? That is the out position. And I'm going to put the out keyword there, out position.x, okay? But there's a problem with this. So this position.x, it tells me that a property or indexer may not be passed as an out or ref. Okay, just letting you know, right? So sometimes what we need to do, my friends, is something like x and y coordinates, you know, like let's say temp x and temp y. So if I say something like float temp x and temp y, I'll kind of make that into, you know, little variables, temp x, temp y, or you can call it x input. Let's put that, and that may be better. X input, y input, however you want this. Y input, okay? And then here, instead of doing it directly, we can just do that. So x input, right? If this is true, that doesn't error out anymore. So if this is true, then if we're able to try parse this, then and only then do I want to, because I've read it in, and I've read it into my inks input, I want to put this now into my vector2d. I can say that position.x, right, is equal to x input. That is legal, because here I've read it in, here I'm assigning it to my position.x. Okay, let's do the same thing for position.y and console right. Now this is really great because if it works, that's fantastic. If it doesn't work, well, there's a problem, and we're going to kind of do that. So give me the y coordinate now as an example. Try parse, put it in the y coordinate, and then read it in to the y coordinate of the position vector. Right? That's what I'm saying to do, right? Now, one thing that's missing here is an else, right? And again, there's a couple ways to write this. So what happens if I don't get good input? Someone gives me an A or a B or something else, some other character that doesn't make any sense. Well, I want to go and do this again, right? So if this is wrong, if this fails, right, then I can make a check. I can use a Boolean to check to see, I'm going to go back and do it, right, as an example. So I want to do this at least once, right? And I can say that I can have some checks. So I can say bool. And then I can make it so that the, remember we did this before, you know, the x input is incorrect, right? So x input incorrect, right? And I can also say that the y input is incorrect, right? If I was to do this just by chance, what are the default values of Boolean? Does anyone know? What's the default value of Boolean data? What's the default value of float data? There's default values here, by the way, right? False. Very good. So false, these are already false. So I can say that if the float is good, then I can also say that my x input incorrect, you know, as an example. I can also reword this. Instead of incorrect, we can make it more positive. Let's do that instead. X input correct, or complete, whatever you want to call it. I'm just being explicit here. So yeah, so these are false. So I can say that x input correct is equal to true by default, right? So normally it's false, now it's true. Else, well, we don't need an else. What we need again is we could put an else. We could say something like else, and we could say something like console.write, right? And here's like an error message saying something like please enter a floating point, a number value for x. All right, And then what this is going to do, I can add in a console write line again, just to give me some space around this thing. And I can also do console write line that says error, right? So console write line error. Let's format this a little bit, right? So something like, you know, something like that. So console write line error, you know, as an example. Please enter. So we're going to really highlight to the user here that something is wrong just happened. Please enter a number value for X, right? And then what we want to do is loop back up here and do this again, right? So what we can do, right, is we can say, two ways we can do this. We can say while do this, right? You know, as an example, or we can also use a do while, right? So it's really up to you what you want to do. But we're going to use a while loop. So while, and we're going to say while. By the way, we can structure it just by typing while, right? And the expression. So we're going to say X input, while X input correct, right? And we can say that, well, while it's not correct, then do this, right? So this is kind of important. And then what I want is I want to grab all this stuff and put it here, right? Now, here's where the while needs an kind of a explicit, you know, kind of initialization. So what it's really looking for is saying something, well, you're going to use me, if you're going to use me as a variable, if you're going to use me as, you know, if you use X input as a X input correct, then please initialize, is what it's saying. So you can say that it's false. Now it's going to take away that error, right? So it's explicitly looking for that to happen, right? Again, this is only one way of doing this stuff. So you have a little while loop, and it's going to keep asking me for input until, you know, I enter the proper input. Okay, so this is kind of our check. Let's do the same thing with our other check. So again, we'll do a while, and then we'll say not y input correct. While let's do this whole thing again. I'm just going to grab all this. So this is good. This is this part, right? The if statement. And the only time it's going to be correct, right, as an example, is if we enter correct data and it converts. So we'll say y input correct is equal to true, right, which will get us out of here. It'll stop this from happening, right? It won't be otherwise, else we want this piece in here. I know this is long, but this is kind of good checks, right? If we're going to enter information. If I'm entering data, I definitely want some way of making sure that, you know, the data that I enter is correct. And so now we've done our checking, X and Y coordinates. Okay, so for X and Y. Let's check to see this part and see if it works. So again, I'm going to just start it. And I'm going to say, you'll see what it looks like. X coordinate, I'm going to type in A. It says error, please enter a valid value for X, a number value for X. Let's say it's 2. And then Y coordinate, enter a value for Y. I'm going to say, you know, 3, and then we're good to go. Okay, so it kind of takes those values in. So that those checks worked for us. Okay, so X coordinate, Y coordinate. We know we're going to get proper values now, okay, for this stuff. And we're assigning it to the position of Y and the position of X, right? So that's what we're doing. Now, what I want to do, and this is the file part, I want to output what we just entered to a file. So remember what our example is, going back to our PowerPoint, right? My PowerPoint says my file stream output file is new, file stream, some text. This is one way of doing it, by the way. Let's just do it this way this time around. So file stream, right? And again, file stream itself is the class. Output file is what we're using. So we'll call it output file, right? Instead of out file. That's equal to a new file stream. And it listens for a couple things. There's a bunch of different overloads that it's telling us that we can use, right? So the name of the file, string path, and then the file mode. Those are the defaults that I have. And then there's other ones. Okay, so name of the file that I want to look at, we're going to call it positions.txt, which is what we made already inside the debug view. And then the next thing that I want in here is the file mode that I want to use. File mode create, right? Now remember what file mode create does. If I go back out to some of these examples, creates a new file. If the file already exists, it is overwritten. Okay, so that's the one I want to use. Okay, so file mode create. Okay, and then I also want this idea of file mode. Sorry. File access write. So what kind of file access? If I don't specify, I don't have to specify. If I want to read write, I can do that here. Read write means now it won't be an output file anymore. It'll be a file or whatever it is, right? But here we're just going to say just write. So I'm only writing to my file in this particular case. And that is just an object of type file string. So it doesn't really, we're not there yet. Okay, we haven't actually created the file or done anything with the file. We've just created a file stream called output file. Okay. The next, what we want to do is we want to create a stream writer. So stream writer. Okay. We're going to call this, you can call it writer or outstream. We'll call this writer. Is equal to a new stream writer, and it takes a stream, right? So I want to do output file as a stream. Okay. So you can see here that it's clear. That's exactly what we're doing. Writer output file, right? And then we want to do something. We want a console write line, but we want to, instead of a console write line, we want to do a writer write line. Okay. So now let's try and think about this. So writer dot write line, which is this one, and we already got our input, which is fantastic. So what do I want to do? I want to output my vector, which is my position dot toString. Okay, so that's what I want to output. Okay, and then I want to clean up, which is I close down my writer first in the reverse order. So writer dot close. And I want to close down my output file, right? Output file dot close. I want to do those things because that's the cleanup piece, just like it does here. So notice the writer and then the output file. Okay, I just call the output file instead of out file. Okay, so that's what this does. So here first, so step one when we do our writing, right? Set up our streams. Okay, first part is the file stream itself, almost like an object that you can configure the output location and file mode and so on. And then once you do that, step two, really, in this case, write to the stream. Okay, and this is using the writer. Writer itself does the writing. Okay, the output file itself is the stream that you're writing to. And then step three is cleanup. Okay, so those are the three steps you need for writing to a file. Okay, reading from the file is very similar. But let's see what happens if we just do these steps. So press play, and I'm keeping my eye on the time here. And if I type in 5.3 and 2.7, well, it did something. Let's check to see. We don't know what it did, but we wrote something. Let's see if we can see what that is. So again, I go to Solution Explorer, and I'm going to go to right click on my solution. I'm going to go Open Folder in File Explorer. I'm going to go into my solution. I'm going to go into the bin debug folder and look in my positions.txt. Double click on this thing. It should bring up my editor, and sure enough, I see 5.3 and 2.7. So I wrote those values out in my nicely formatted way. Yay, positions.txt. So we used our vector 2 for the first time. It actually worked to do something. Yeah. So that's how you write to a file, right? Using our stream, file stream and stream writer. There's actually shortcuts to do this. We'll talk about that in a bit. But let's keep going. All right, so that is writing to a file. Similarly, when we read from a file, it talks about delimiter data and all that kind of stuff here too. We can set up a delimiter. A delimiter means a comma. If I want to read in a comma separated file, as an example, or I can write out in a comma separated file. It's totally fine. I can use the delimiter for that. And our write line, you can kind of put together a comma delimited fields if you want to that we're outputting. That's what they're doing here. They're just kind of encoding what they're writing to the file. Now, one thing to note is anytime we write to a file, what we're really doing is we're encoding that file in our own special way, right? Like I've just done that. When I wrote to the file, I wrote positions, but I also wrote open bracket, right? As an example, the position, the X position, comma, space, and then the next thing, which is the the Y position, and then close bracket. Okay, so I've written those things in there, and that's tricky because if I want to read stuff in again, I need to ignore when I bring it back in. Okay, so let's just do that. So next, so that's how we can write. Here it's writing sequential data. So here it's writing some data, the name, and some other data as an example, right? And it's comma separated. And this is nice because if I was to read this back in, it's pretty simple. I just know what the delimiter is, and then I can ignore the delimiter, and it'll split up my fields this way. Okay? We don't have that right now. So now we're going to do the same thing with reading. Okay, so reading from a sequential file. This is reading any file. So again, file stream, file name, file mode open, right? File axis read, we're reading. We're going to use the stream reader, and the new stream reader, we're going to use the in file, whatever that is, to get. Now, here's the trick. When we do a read line, right? When we do a read line, we take in an entire string, and we need to do some string manipulation in order for us to do this. Notice it's using the split method of the string, so we can split off or kind of start reading from that particular line. Okay, we're gonna have to do the same thing here because if you think about it, right, we have a different setup than these guys do on our in our PowerPoint. Okay, so if I go again to Open File and File Explorer, and if I go into, I'm showing you this a bunch of times so you know where your file is, in bin debug, and you look in positions, I'm going to read in, my string is going to look like this. So I'm going to have to take in my string, ignore somehow, or knock out the first bracket, read this first piece of data in, right, and then ignore the comma, ignore the space, right, and read in the second piece of data, this. Okay, I'm just letting you know, and then ignore the last part. So we're going to have to create some string functionality in order for me to do this. That's what we're going to do for the remainder of the day today. All right, and then we'll hit other stuff because that's important. Okay. So then, how do we read it? How do we read in our file? So this is for steps for writing, right? Well, steps for reading are kind of the same. We've closed it out. So we can say steps for reading files, right? So what is step one? Well, it's very similar. We're just going to copy all this for a second, okay? And go in here. And instead of my output file, we're going to have an input file. Input file. Output with a capital P. Yay, Tom. All right, and instead of writer, we're going to call it reader. Instead of stream writer, we're going to use stream reader. Okay. All the same kind of stuff. Stream reader. We're reading positions.txt. File mode, right, is open. Right? Open. And file access, we're being very specific here, is read. Okay, so only one thing. Writing, reading. Reading is a little bit more tricky because, like we said, so we're getting things inside of our input file. Oh, darn. Input file. We're getting stuff from our input file, and we want to do a reader.close and our input file.close when we're done. This is all the same. So instead of writing to the stream, we are reading from the stream. Read from the stream. Okay? So that's the thing. Instead of writer.writeLine, we're going to reader.readLine. And it's got to go somewhere. Okay? So reader.readLine is going to output a string. So that's the input string, right? We're going to make this as a thing. So we're going to say that var input string is equal to this. Okay? We know that input string is actually a string, so we can change our var to a string. If it was something more complex, I might leave it as a var, right? So here I've written the whole string in, but I can't assign it back to anything. I can't make a new variable or whatever and assign it back because it's a string. I want to kind of extract, right, our x and y values. That's kind of important to do. Our x and y values from the string, from our input string. Okay. So that's kind of the thing we want to do. But for now, let's just print out what this string is to the console. So console writeLine, and we'll output input string. Okay. So we'll also do some other things here. We'll say in the beginning, we'll do a console writeLine and another console writeLine just to format our console a little bit. Console writeLine, and we'll do kind of one of these again. Okay, it's not going to be the same size as that. That's okay. Or maybe we'll make it a different thing. Instead of dashes, we'll make it equal signs just to make it so that it's different. Right, there we go. And what we'll say is that reading file or something like that. So we can see that the output of this thing. So we'll do this twice. We'll do this. We'll kind of highlight this like this, and we'll do a console writeLine that says something like reading file. Okay, so reading file, console writeLine. Again, I can use \n for this, but I'm not going to. I'm just going to do this. And then we do our input string or whatever. And what we want to do is we want to console writeLine the input string. We'll say, that's the data that we wrote that we're going to write out to the console writeLine, whatever the input is. Okay. And just like we did this here, just to make it so that it's the same, I'm going to go up here way at the top. Whenever I do our file write, then we're going to do the same thing. We'll say writing to the file, writing to file. Okay, writing to file, reading from file. Okay, nice. So kind of similar as what we've done. Let's see what that looks like. So again, I can start and I can go, okay, my coordinates are different now. I'm going to do 5.5 and I want to look at 3.7. So they're different coordinates than I used last time. It's going to say writing to file, reading from file, 5.5 and 3.7. You can see that clearly I read from the file. That's how I got this input string. Okay, that's where it came from. It came from the file. So I read pretty good. I read and wrote. But this doesn't make any sense. If I want to use this data now, it's one thing to print out the data. And what this is really called is encoding and decoding. Or another way of looking at this is serializing the data. I'm putting it up to a file and deserializing the data, right? Now the smart thing to do, is when I send it out to a file, right? And when I use my toString method, right? There's two things I can do. One, I know my toString method sends out something that I want to do to console, right? So to be smart, why would I want to send something out that I have to do a lot of work to read back in? That doesn't make any sense. Make sense? So toString is nice as an example if I was, if I was going to do something like, outputting to a console. That would be nice. toString. It's nice, good output, or whatever. But if I want to write to a file, then toString, the way I've written it, not good. Okay? So maybe what I need is another method to help me out. I could do some fancy, and I'm going to do it in a second, string manipulation with the split as an example to get my file back out. But I want to prepare myself to do it easier with my class, right? Don't do it like this. That's going to cause you more work at the end, right? So in my Vector2D class, right, I have right now an override toString method. Let's make another method with the class diagram. Okay, so here's my vector. Let's use the class diagram to do another method. So again, I'm going to go right click. I'm going to scaffold it out, a new method. And the new method that I'm going to make is encode, right? And I want to encode, to text. So text encode or something like that, right? So text encode, right? That's what the method's going to be called, text encode or string encode. How about that? String encode. Okay. So string encode basically means I'm going to convert my x and y coordinates to string. Okay, that's what it means. And if I look at, I've just scaffolded this method out. It doesn't returns void right now. Again, I can do some additional information. I can go to my string encode. Instead of it returning void, I can change the return type to string right here. Okay, that's an important way of doing it. So now it's changed here in my map. This is my map for my classes. I only have one class that I'm using right now. It's totally fine. And here I've got my string encode method that's kind of been scaffolded out for me, nice. Except I have to do this. So what am I going to do? Return, instead of returning all of this, that doesn't make sense. Instead, I want to really compress all this. I want to remove this stuff ahead of time. This.x, I want to, use the comma delimiter to comma delimit, kind of delimiter all the things that I'm entering and get rid of the brackets. So, when I'm reading things in, when I encode something, I want to encode it in the easiest way that I can, kind of put it up the file. When I decode it, I want to read it in a certain way, okay? So encode and decode, right? So let's go back out. So now I'm going to go back to my program, and instead of using position.toString, let's use position.stringEncode. So this will give me the string that I want out to the file. Let's see what that looks like. So again, if I run this thing, I can say something like, okay, 10.0 and 3.5. And you can see that I'm going to get it coming back in an encoded fashion now, right? So this is encoded. There's no brackets. This is comma delimited, and this is great. So now I can go back and use what we have in the PowerPoint, because the PowerPoint basically says this. I want to read my field, but I want to split it with my delimiter. My delimiter split is actually a string function, and delim, this delimiter right here, I can explicitly put that in there. It's going to create fields. Notice it says fields, where I'm going to get an array of fields broken up by the delimiter. I'm going to get two fields, x and y in this case. Okay, does that make sense? So this is where I re-encode everything. I re-encode from fields. But we're going to be smart. We're going to build in our encoder, right, as an example, inside of our vector2d object. So in my vector2d object, I'm going to use the split to encode, right? So, but instead of doing it here, when I write to the string, I'm going to use a vector2d object to do this. So here, my vector2d object is string decode. I'm going to write it now by hand. So string decode. I'm going to take in a string, right? Okay? And I'm going to, when I enter it, it's not going to return a string. It's going to return void, actually. It's not going to return anything. I'm just going to take in the string, and I'm going to apply it to my x and y coordinates, the other way around. So I'm going to say that my fields, just like we said, okay, or we'll call them coordinates, that's equal to my coded string dot split and by the delimiter, comma. All right, it's going to give us an array of coordinates, a string array. Notice that what it does, that it gives us a string array. We'll replace this with string array. String array. Okay? String array. So the comma, the split function, uses whatever delimiter we want. That's the separator, is what it's called, right? Param separator, so comma. So I'm going to use the comma, delimit it, and then put it into its string array. I'm going to have two components, right? 0 and 1, right? And I want to say that now this dot x is equal to coordinates 0, right? And I want to think about this. I'm going to take this is still a string. I want to convert it to a float, right? So I want to do that try parse again, right? But let's just trust the fact that it's going to be converted because we're reading from a file and we're reading from a good file. If I wanted to, though, I would be able to put in there error reading, like if somehow I wrongly encoded it. I'm just running out of time here, or else I would do it for you. But I want to use this convert to float to single, and I want to take my coordinates, right? I want to convert it to single, right? And make it the x coordinate. And I want to do the same thing for the y coordinate. So y, and here's my y coordinate. Okay, so there's a way of convert. This is one way of doing it. So I've got a string encode, I've got a string decode, I take in a coded string and I convert it. I actually align it with my x and y coordinates. Okay, and these things are outputs, and this is an input, string decode, right? And by the way, when I say string encode, I could say, you know, vector encode, or just call it encode and decode, right? So coded vector string. I could make these methods make more sense contextually. But let's go back. So here, what I have is I read my input string and I output my input string just to show you what it is. So we could say something like console write line. Actually, we'll do it in one for us. We'll say string read from file, right, is this, my input string, okay? And then I close up shop. I do all this kind of stuff. I close up, and I still have my input string. And what I want to do is I want to decode my string and add it into my vector. So I can say position dot string decode. I'm going to pass in input string, right? Input string. The string that I read from the file, I want to decode that string, split it apart with x and y coordinates, and attach it to my position. So my position now is going to use this input string as my position, okay? So then what I can do is I want to print that out. So I'm going to say something like, and some detail. So console write line, I can say something like decoding string, decoding coordinates, right? I did this, and then I'm going to output them. Console write line. As an example, new coordinates are plus position dot toString. That's okay, because the toString is for the console. It should not be for my file, because I want to encode my file properly, right? Position dot toString. Okay, let's see if this all works. So again, right, start. I'm going to say, okay, so I got a coordinate, we'll say 7.5, and my y coordinate is 3.3, and then it says writing to file, reading from file. So string read from file is 7.5, comma 3.3, and my new coordinates are 7.5. Notice I'm getting brackets now, 3.3. This is coming from my vector. Guys, it's a beautiful thing, right? So I've encoded and decoded, serialized and deserialized. Okay, you can also call it that as well. Here I'm serializing and deserializing text, but I could also be serializing and deserializing binary. It's the same process. It's just some different code that we're going to use. Okay, so that's what this is doing. So really, when I'm writing to the file, I'm encoding my output, string encoding, right? So encoding for file output, right? And when we read it in, we're decoding for file input. Okay, that's what I want you to think in your head. And by the way, remember we talked about this? Any input we're getting from the user is going to be strings, right? So we've done it a couple ways, right? We've read strings in here, used our try parse to make sure that we're getting proper input, right? We're doing this. This is the first part of what we did today. And then what we're doing is we're using our construct, a vector 2D object, to be able to write out to the file. We're doing it in one, obviously, right? We're writing out to the file, and then we're reading from the file, and we're encoding and decoding. Okay. The things that are left to talk about here, again, we're kind of sitting at page 33 out of 47, right? What it does is it talks about how to search a sequential text file with seek and seek origin, which is something that it can do. It can kind of go through one line at a time and seek forward. And we kind of talked about serialization and deserialization here when we wrote wrote to a text file. Here, what they've talked about is a different method of serializing and deserializing. They're serializing by using a decorator, right? That's what it is. Actually, or a directive. This little square brackets thing is a directive that is basically saying that the whole class is serializable. System.serializable is what this is. So it's allowing us to kind of encode and decode right from the file. Okay? And when we mark it with serializable, this attribute, which is also called directives, an attribute, a directive, a decorator, different ways of calling these little square brackets, right? But when you decorate a class with this attribute, I'll put it that way, right? It kind of marks the class as something that could be used to serialize our data out to a file, okay? So when we do that now, we mark it as serializable, right? That particular class. We can use our formatter, right? Which is something that is built in, a system that's built in, a binary formatter. I can format something into binary and serialize out. Okay, that's what it does. So it converts it, excuse me, into binary, and the whole class is converted to binary, as opposed to me writing each individual text output. Now, when I'm reading it back in, I've got to deserialize it, and it's doing it here by using the binary formatter. We're converting it to an employee in this case, because here what we've done is first we said that this employee class is serializable. And what this does, it takes the entire class and converts it to binary, right? The data, not individual piece parts, as an example. And in here, I only have a vector, x and y coordinates. But if I had a much larger class, let's say, for example, a game object, like a player, and I wanted to output all of the player stats to a file, right? Then it'd be really tedious for me to go through and go health, position, rotation, scale, blah, 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 and then output everything into a text file and then read it in from a text file and deserialize it. That's crazy, right? That's nuts. So binary reading and writing is the way to go, and we can mark it with this serializable attribute. And when we do that, we can actually write to a file and read from a file. Notice that this is what the data file would look like. It's a data file. It'll convert it to binary, so it'll be completely unrecognizable when we do that. And this is the stuff that we might enter some data, get input from the user, and output some stuff to the file. And when it does it, it'll encode the file again with this serialize method. So it'll format the binary file. So now, how does it write? And I'm just going to zoom in here because we ran out of time to do this with you. But here we again, file stream, we create write. We create a binary formatter called bformatter. We make a new object as an example, and then what we do is we take the employee and we convert it into something that we can read from the file. We're reading from the employee number. We're converting it to int32, and we're applying it into our employee class. That's what's happening here. And then while the employee as an example, has not come to an end. We're reading all the objects of the type employee. We're going to enter last name, enter the salary. We're going to keep on encoding the employee. And then we're going to output file with the whole employee object with serialize, which is awesome. So this actually outputs to binary. The difference between our output stream is the same. File name, file mode create, file access write. That's the same, but we're not using a notice our stream writer and stream reader. Where is that? There isn't any of that anymore, right? We don't need to do that anymore. We can just use, once the file is open, we can output there, right? So that's what it does. Okay, that's what our output does. And it says, enter an employee number or N to quit. That's what quits out of this while loop. We can keep entering employees this way, right? Then we just close, we clean up, we close the file, and then on the input way, we do the exact same thing. Instead of it being file access write, we do file access read as an example, right? Instead of create, we use open. And then while the in file, which is this file stream, dot position is less than the in file length, so we're reading each element of the file, then we're going to re-encode everything back into that structure, that employee structure. We're going to say employee is equal to, and we're casting it as, because the formatter, as an example, this binary formatter, we're going to use the same object, but the binary formatter doesn't know what we're serializing. So we need to cast it as a type of employee, which is kind of an interesting way of doing things. And that's how we would do binary reading and binary writing. And I think that's a way better way of doing it, as opposed to doing what we've done, which is creating a, kind of a string encoder and decoder. Okay. Questions around reading and writing files. I think it's a key learning, and we're going to use some of this in a different way in our UI lessons coming up starting next week. Okay. Speaking of next week, we don't just have that coming up. If I was going to look at our lesson structure for next week, right? Let's look at that. So we're hitting week 7, 8 because we're compressed. We're going to have a midterm test coming up, right? And if you notice, here's our schedule. Looking at our schedule for next week, we're sitting at week 7, but our test number 1 is actually next week. Test number 1. So this test number 1 is obviously not going to be in class. We're not going to do a test in class. I'm going to give you the test, and you're going to be able to do it over a period of a few days, right? Rest assured, it won't be enough for you to just to write a test. It'll be a practical test, so it won't be a true-false multiple choice type test. It'll cover everything that is we've been talking about up to this point. Okay, so everything that we've talked about, including file I/O and the stuff we talked about last day, which is exception handling, all that stuff, and error handling. All those things will be included in your test next week. But you'll get your test starting off on Wednesday, and you'll have from Wednesday to Friday of next week to get it done. All right? There's going to be unlimited attempts. It's got to be an individual test, and you will have to record a short video during that time. So it'll give you a chance to, to kind of practice doing a video. The video will be exactly what I've asked you to do here on your assignment, so you'll be doing the exact same thing. And it'll prove to me that it's you and that you know what you're doing on your test. Okay? And I'll also try, I'm just going to tell you this, I'm also going to try to make this test individualized. There'll be something that's different about the test for everybody that's doing it. Okay? And you'll know more about that next week. Okay, that's it for me today, guys. I'm going to stop talking. I'm going to put this up on GitHub. And again, the way I did it with you guys on GitHub before is I went to Team Explorer as an example. We're going to go to Home. I'm going to go, I know that I haven't made this a part of, let's go back actually, Solution Explorer. This is not part of source control, so I'm going to right click here first on my solution. I'm going to add this to source control, right, which is going to initialize my Git repository. I need to do that first. Step 1, add it to source control. Step 2, right, go to Team Explorer. If you don't have Team Explorer, go to View Team Explorer, okay? And then go to Changes. You won't see many changes here because I haven't really added it to, to the source control before. So here I'm going to go to Home. I'm going to go to Sync. But you know what? I don't have a repository. Here it is. I'm going to use the GitHub extension for Visual Studio 2019. I'm going to click Publish to GitHub, and it's going to recommend the same name as my project. I'm going to go into Centennial College here as an example and click Publish. And now, my friends, you should have this file. I'm also going to link to it inside of your folders. So I'm going to go to GitHub Centennial College. We'll have that repository right here. I'm going to copy this repository, and then inside of your files for this week, I'm going to make that a new file that you can, a new link that you can get to. So this is GitHub repo for week 7, part 2, right? So there it is. So you also have this one too, just in case, you know, we didn't talk about this last time. There it is. Week 7, part 2. All right. So please, if you haven't had a chance to do that already, practice doing what I did. Go through it in your by watching the video if you need to again. But I would practice, you know, kind of using I/O as well as some of the stuff that we talked about last day, which was exception handling. Because although it may not be part of your abstract plan, it's nothing for you to input from the user or anything like that. It will be part of your test next week. All right, so it's good for you guys to know how to do it all. Okay? Any questions before we go? Sorry, sir. Is the test will be questions and answers or hands-on? It's all hands-on. I'm not going to make it Q&A. Like, it's not going to be like true, false, multiple choice. It'll be hands-on. You'll have to create something. Okay, so that's the answer for that. I'm going to stop recording now and hang out for any questions you guys have.